Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am taking thermodynamics in chemistry, and in this lecture, this is lecture number 33, in which I will explain you what is entropy with pressure and temperature variables. Okay, last time we saw the entropy change when volume and temperatures were variable. So now we will have to see entropy when pressure and temperatures are variable. So let P1 be the pressure in initial state and P2 in the final state. So here P1 V1 upon T1 is equal to P2 V2 upon T2. So from this we can write V2 upon V1 is equal to P1 T2 upon P2 T1. Now when we take volume and temperature variable, we derived two formulas. One is delta S is equal to NCV ln T2 upon T1 plus NR ln V2 upon V1, and this was equation 4 in previous lecture. For 1 mole of ideal gas, we have this formula: delta S is equal to 2.303 CV log T2 upon T1 plus 2.303 R log V2 upon V1. This is equation 5 in previous lecture. Okay. Now here we have derived that V2 upon V1 is equal to P1 upon T2, P1 T2 upon P2 T1. Substitute these values in equation 4. So substitute V2 by V1 in equation 4. So we get delta S is equal to NCV ln T2 upon T1 plus NR ln P1 T2 upon P2 T1. This is equal to NCV ln T2 upon T1 plus NR ln P1 upon P2 plus NR ln T2 upon T1. So here ln T2 upon T1 is common for these two, and therefore we can combine them. So it is equal to N CV ln T2 upon T1 plus NR ln T2 upon T1 plus NR ln P1 upon P2. This is equation 6. Or equation 6 can be rewritten like this: delta S is equal to N CV plus R ln T2 upon T1 plus NR ln P1 upon P2. Okay, and you know that Cp minus Cv is equal to R. Therefore Cv plus R is equal to Cp. So substitute these values over here in this equation. So we write that delta S is equal to NCP ln T2 upon T1 plus NR ln P1 upon P2, or delta S is equal to 2.303 NCP log T2 upon T1 plus 2.303 R log P1 upon P2. This is seventh equation. Okay. Now we will study different cases in this case. So the first case, case 1. At constant temperature for an isothermal process. So when temperature is constant, that means T1 is equal to T2. So for such process, equation 4 and equation 6 take the form like this. Delta S at constant temperature will be 2.303 nR log V2 upon V1, and delta ST is equal to 2.303 nR log P1 upon P2. So this way, this is a formation of different conditions when constant temperature is taken. This is equation 8, this is equation 9, okay, when temperature is constant. In isothermal expansion, V2 is always greater than V1, or P1 is always greater than P2. Hence, delta ST is positive. And in isothermal contraction, where the conditions are opposite, that is V2 less than V1 and P1 less than P2, therefore delta S at constant temperature will be negative. Okay. Next case, case number 2. At constant pressure. So when we take constant pressure, that is called isobaric process. Here we know that it is P1 is equal to P2. Therefore, equation 6 will be delta S at constant pressure is equal to NCP ln T2 upon T1, or delta S at constant pressure is equal to 2.303 NCP log T2 upon T1, and this can be equation 10. Okay. Now we will take the third case in which volume can be constant. So volume is constant for case 3. So here we write case 3 where volume is constant. At constant volume, that can be isobaric process. So here V1 is equal to V2. So the equation 5 will be delta S at constant volume will be CV ln T2 upon T1, or delta S at constant volume will be NCV ln T2 upon T1, or delta S at constant volume will be 2.303 NCV log T2 upon T1. So this way we have different formulas for different conditions. Okay. So this can be equation 11 when volume is constant. So these are the different cases for determination of entropy. Thank you so much.